This week we're talking about fluids, and fluids are anything that, any substance that can take the shape of a container or anything like that. And here are two basic examples of fluids. This beaker is filled with canola oil, as it happens, and this beaker is filled with air. And so they're both filled with a fluid. So gases like air, oxygen, nitrogen, they're fluids. And then liquids like canola oil and water, um, mercury at room temperature, they are fluids. There is another distinction between them though. If you look at this one, it's not compressible, which means if I take a plunger and put on top of this, I can't squeeze it down at all. But air, as you know, is compressible, and so if I take a plunger and put on this so it's sealed around the edges, I can compress the air. And so there are compressible fluids and incompressible fluids. When we talk about fluids, we often talk about the density of a fluid. So if you take a certain mass of a certain volume and mass and take the mass divided by the volume, that's its density. Water is 1,000 kilograms per cubic meter. That really comes from 1 gram of water is 1 cubic centimeter. It also works out to the definition of a liter, which is one kilogram of water is 1 liter. So when you pick up a kilo of soda, when you pick up a liter of soda, that's about 1 kilogram to give you a feel for what a kilogram is, because soda is mostly water. Okay. Um, and to look at this a little bit differently, I think you guys can see this, right? Different things. Water is 1 kilo, 1 kilogram per cubic meter. Blood is about the same as water, but a little bit denser. Seawater is denser because its mineral content. You can see that mercury is 13, 14 times as dense as water, right? Now you go to the other side, air, 1.29 times 10 to the minus 3 are really just 1.29 kilograms per cubic meter. Water is 1,000 kilograms per cubic meter. So if you look at a cubic meter of air, that's 1.29 kilograms. And if you look at some of this, you'll begin to understand why different things are problematic. Carbon dioxide is heavier than air, and so carbon dioxide in a room where everything's kind of still is going to drift to the bottom. Carbon monoxide is going to drift up. So if you have an issue with carbon monoxide, you need to go to the floor. Hydrogen is going to drift up because it's less dense. Helium is going to drift up because it's less dense. Methane is less dense. Nitrogen is slightly less dense, right? Nitrous oxide is heavier. Um, and so the relative density of these would determine their distribution at some level if everything's completely still in a room. But the reality is the motion of molecules in a room help distribute things evenly. The only ones that you really are going to move around a lot are the ones that are way off, hydrogen and helium. Um, all right, that's it for the intro on what fluids are, and then we'll get into more about fluids.